All right. Hi, everyone. Let's go ahead and get into reflections on the coordinate plane. So remember, reflections are, think of them like mirror images. So as we get into these notes, think of reflections as mirror images on a two-dimensional plane. So a reflection flips a figure over a line of reflection in order to create a mirror image. Okay. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. So what they mean by that is that no matter the distance, it's always the same point or same space across from the line of reflection. So, excuse me, if we're looking at this first image here, first we need to identify your axes, which this is the y-axis, this is the x-axis. If I look at this first image, I can see that this image is flipped over the x-axis. Okay? Then if I look at the second image, I can see that if I label again X and Y, these two images are reflected over the Y axis. Okay, notice they're the same distance apart and they're looking at each other like a reflection should. So if we go down here and we look at number one, our first example, it says reflect the figure shown over the Y axis, and we're going to record the coordinates of the pre-image and image. Okay, our goal is to see what happens so we can figure out what our rule is. So if we look here, remember, label your axes, X and Y, and we notice that how far is W from the Y axis? Well, it's two spaces away, so on the other side it also has to be two spaces away. And we'll label this W prime. Okay, on the other side, Y is also two spaces away from the line, so we're going to make that two spaces away as well. And then the last point is your X. Well, X is 7 spaces away, so we're going to label this 7, or we're going to count 7 away from here. So 1, 2, 3, 4, 5, 6, 7. And here's our X prime. Okay, if we connect all our points, we should see that this is indeed a reflection across the axis. And I know this isn't going to be a perfectly straight triangle, but we can see that this is clearly the same distance apart on both sides. So now we're going to go ahead and list our coordinates. So we have W, X, and Y. We have W prime, X prime, and Y prime. Well, W is 2 comma 6. W prime is negative 2 comma 6. X is 7 comma 4. And X prime is negative 7 comma 4. Y is 2 comma 2. And negative Y prime, our last point, is negative 2 comma 2. So now that we have our points, we need to look at what is happening from our pre-image, which is our original. I'm going to label that O, and to our image, which is our new. Okay? So what happens from original to new? Well, what happens to my X value? If I look at W, my X value went from 2 to negative 2, which we would say X becomes opposite. And then if we look at our Y values we notice from 6 to 6 it stays the same. So our Y value stays the same. Okay, now last thing we need to do is how do we represent that algebraically? So if we say this is my original X comma Y, we need to figure out, well, what happens to the new? Well, we said that X becomes opposite, so we're going to say opposite of positive Y is, our positive X is negative X, and our Y stays the same. Okay? So if we think of it this way, If it's in the name, it stays the same. So if it's reflection over the y-axis, the y stays the same and the x changes. So here is our algebraic representation here. Okay. So now let's look at our reflection over the x-axis, which is the example below. It says reflect over the x-axis, and notice we have this triangle down here at the bottom, DEF. Okay, well, just like the one at the top where we did across the y-axis, we're going to reflect across the x-axis here. It has to be the same distance to the number line. So if D is 2 away from the number line here, our new D is going to be 2 away as well. We'll label that D prime. Our F is 7 away from 0, our number line. So then our new F has to also be 7 away. Remember, with reflections, as it says in our notes, that each point is the same distance away in a reflection as it is from its original. And then lastly, E prime is 7 away here. Okay? So we label everything, connect our dots, and we should see something that looks like an image staring back at the other shape. Okay? So we'll go ahead and put these points in really quickly, and then we can figure out what happened to our points. So our pre-image, our original, and our image is our new. So we have D, we have E, and we have F. Okay? So D we know is 2, 2. E is 7, -7, and F is 2, -7. Okay, so now we're going to look at our image. So we have D prime, we have E prime, we have F prime. D prime is 2, D prime is 2, +2. Sorry, that's a 2. The original D was 2, -2. That's my mistake. E is 7, 7, and F is 2, +7. Okay, so we have our new points and our old points, and we need to compare the two. So what happened here? On this one, our x values stayed the same. As we look at E, we have 7 and 7 for x value, so x stayed the same. And our y value became opposite. We went from -7 to +7. So our y value becomes opposite. Okay? So how do we represent that algebraically? Well, if our x, y, our original value here, looks like this, well, we said that x stays the same, so x stays the same, and then y becomes opposite. What is the opposite of positive y? Negative y. Okay, so there's our algebraic rule for reflection across the x-axis, and here's our algebraic rule up top across the y-axis. And we'll continue on to our second video.